Hello student, welcome to the lecture. In this lecture we are going to discuss the MO energy level diagram of some homonuclear diatomic molecules of second row elements. In previous lecture we discussed the same one, homonuclear diatomic molecules, but these are in first row element. Now in this lecture we are going to discuss the homonuclear diatomic molecules of second row elements. In that we are going to discuss the energy levels and the order of energy levels regarding with this homonuclear diatomic molecule of second row element. Now let's start. Before starting the MO energy level diagram of lithium molecule, we are going to discuss some energy levels regarding with this second row element, because in that there is a 2s and 2p orbital are present in that molecule. So depending upon that orbital, there will be the electron filling and energy of that particular orbital is different. So this element contains and 2p. There will be the 2px, 2py and 2pz orbital is present. Overlap of this 2s and 2p produce and 2s orbital produce sigma 2s and sigma stars 2s, that is bonding and anti-bonding molecular orbital, that is bonding, and this is an anti-bonding molecular orbital. Likewise, when overlap of 2p and 2p orbital produce sigma 2pi 2p, sigma 2px and molecular orbital. Overlap of 2p1 and 2p1 orbital produce. This is an atomic orbital. Later on produces by overlapping, it will be produces the bonding and anti-bonding molecular orbital. Produce overlap of here pi 2p1 and whereas overlap of 2pz and 2pz orbital reduce the pi 2p1 and pi 2pz molecular orbitals. Similarly, pi 2p y and pi 2p z antibonding molecular orbital have equivalent energy. So this orbital is called as a degenerate orbital. So the energy sequence is like sigma 1s, sigma 1s star, that is an antibonding molecular orbital, 2s, sigma 2s, sigma 2s star, then pi 2py, pi 2pz, pi 2py, pi 2pz, sigma star 2px, which have a large energy. So this have an equivalent energy sets of orbital. So this is called as a degenerate sets of orbital, as we already mentioned here. So on the basis of this energy criteria, we will discuss the lithium molecule. So here lithium, the one atom of lithium is combined with another atom of lithium. So there is a formation of Li2 molecule. The electronic configuration of lithium is a 1s2 2p1. So in inner shell there will be the two electrons, and in p orbital there will be only one electron. So these are the 3 electrons total, and these 3 electrons, so in that orbital this is a low energy orbital which cannot take part in bonding, but here this is an orbital which take in bonding. So let's discuss this bonding and anti-bonding molecular orbitals of lithium atom with respect to MO energy level diagram. And 2p. So in 1s there will be, so here that is a 2 orbital, we can take 1s and 2p. So here first we are going to then describe the 1s orbital here. That is 1s. Here that is antibonding molecular orbital, here also antibonding, here that is molecular orbital. Orbital there will be 2, that is sigma 1, as we know that these are sigma 1s and this is a sigma 1s star orbital. In that there will be the 2 electron also. Here that is MO sigma 1s, that is sigma 1s star. So this 2 electron will be occupied. Likewise this here in antibonding there will be 2 electron, here again antibonding. Now the in molecular orbital there is a bonding and antibonding. So in bonding there will be 2 and in antibonding also there is a 2 electron. Now what about the 2p orbital? In 2s there will be only 1 electron. You can write here. 2s one, that is one, here also one. It is a 2 electron in anti-bonding, that is a sigma 2s orbital. This is of lithium molecule. So here there is no electron and sigma 2s anti-bonding orbital will be remain empty. So this is an MO energy level diagram for lithium molecule. Now what about the degeneracy or the energy world in the 2s orbital of one lithium combined with 2s orbital of another lithium to form the sigma 2s orbital, which contain one bonding and anti-bonding molecular orbital. So this is a 2 electron. So that's why the 2 electron is here for sigma 2s. As we know that used to be also called as a stabilization energy. Now what about the bond order of Li2 molecule? As we know, bond order. That is half. That is P. Number of bonding and divide minus number of bonding minus number of anti-bonding molecular orbital. So here number of bonding orbital that is 2 minus number of anti-bonding orbital. Here in anti-bonding orbital there will be the nothing, so that's why that is a 0. Means these electrons are paired, so this is the diamagnetic molecule. One means that is a plus half and minus half spin, so there will be the 1, and this is a diamagnetic. So here this is all about the MO energy level diagram of lithium molecule. Now the electronic configuration of 1 beryllium, that is 1s2, 2s2. Here that is a total 4 electron. The 2s orbital of one beryllium combined with 2s orbital of another beryllium atom to produce the molecular orbital. Now let's discuss this way. That is 2 electron here, 2 electron here, and 2 electron here. That is a sigma 2s, that is sigma 2s antibonding molecular orbital, that is 1s orbital. Here also that is 1s antibonding atomic orbital, that is in molecular orbital. This is one beryllium atom, that is in second beryllium atom, and this is a formation of Be2 molecule. So here that is a 4 electron. In 4 electron, out of 4 electron, 2 electrons will be enter in sigma 2s orbital, and 2 electrons will be enter in sigma 2 star orbital. That is an antibonding molecular orbital. So here there will be very simple molecular energy level. That is KP. That is an energy. This is a energy which indicate the electronic configuration. Sigma 2s star, that is now what is about the energy? energy evolved to the bond order for B2 molecule, that is bonding into non-bonding. So there is a bonding, there will be 2 electron, and in anti-bonding also there is a 2 electron. So our rule for bond order, that is we already discussed, half into number of bonding and minus number of anti-bonding molecule or orbital. So here that is 0. 0 means that there is no any bond formation in between the beryllium atom. Bond order is nothing but the number of bonds to form molecule. So as we know that here that is a 0 bond order means there is no existence of beryllium atom, or there will be no any bond formation means 2 beryllium atom, there is no any bond means the molecule does not exist. So here the 0 bond order indicates that. So we will discuss the B2 molecule, that is boron molecule. That is B2 molecule is 1s2 2s2 2p1. So there will be the 5 electrons. In that 5 electrons, as we know that the only 2p1 orbital, that is x orbital, 2px orbital take part in bonding, whereas the other are not take part in bonding. With the help of MO energy level diagram, so in that there is a 1s2, 2s2 and 2p1. In among that only 2s and 2p1 taking part in formation, but generally 2p1 is most form bond with the another boron atom instead of this. So this is inert, so we cannot write here the box diagram for this 1s. We just putting down the 2s and 2p here over here. So here that is 2s2, because in 2s2 there will be the 2 electron for 2s, that is atomic orbital of 1 into s, and this is another 2s. So here sigma 2s, that is sigma 2s star molecular orbital and antibonding. So we can write for 2p, we know that in 2p there will be 3 orbit, that is 2px, 2py and 2pz. So in there will be only 1 electron which is in 2px. It is B2 molecule. 1s2 2p 2p 1 5 electrons. So we can write here so here So this is an anti-bonding one. This is an bond. Here also one, that is a 2p. This is a boron atom. Here also a formation of boron atom. Here that is a B2. So this is the MOT diagram for B2 molecule. Now what about the energy vault? Has to be, so the bond order of that molecule is equal to half number of, as we know that the bond order is the number of bonding minus number of anti-bonding molecular orbital. Bonding is 6 and anti-bonding is a 4. That is 1 means it is a diamagnetic, but here there is a 2 electron in pi orbital, means that is an paramagnetic one. So molecular orbital electronic configuration of B2 molecule can be written as, that is sigma 2s2 anti-bonding molecule, that is 2p-y1 pi 2p-z1. This is the electronic configuration. Now we will discuss the C2 molecule.